Today, I'll be talking about our final project, which is parameter-efficient fine-tuning for video text retrieval. So first, I'll be going over our general problem. So what is video text retrieval? Video text retrieval is the task of retrieving the most relevant video given a text query, as well as the opposite task. This task is challenging because videos can contain many redundant frames, some of which aren't even included in the caption. Captions can be ambiguous or incomplete, as well as real-world video-text relationships often being very complicated, such as one video could match to multiple captions or one caption could associate with multiple videos. Why is VTR important? Well, effective VTR powers a bunch of other different products, and it can improve content discovery, accessibility, and organization across massive online video platforms. There are some limitations of existing approaches in VTR. For example, some of the earlier VTR models, such as clip and clip-for-clip, capture coarse global features but struggle with fine-grained alignment across specific frames and words. This is caused, like mentioned before, by the redundancy and ambiguity in VTR, such as the irrelevant frames and words. Additionally, later on, we have another model called XClip, which we find is a strong baseline as it introduces multi-grain contrastive learning, which helps improve semantic alignment and filters out irrelevant content. So, like mentioned before, here we have some related work. We have XClip, which is a multi-grain contrastive learning, such as it has video, sentence, frame, word, as well as other cross-grain approaches. It fuses all these together in this module it calls the AOSM, which highlights the most relevant frames and words. Another paper which is relevant, which is TeachClip, which shows that holistic video features distilled from fine-grained models can rival much heavier architectures, and it inspires a lot of our exploration into lightweight adapters and more efficiency-oriented improvements rather than full-on fine-tuning. So our overall task is to re-implement XClip on two different datasets to first establish a strong baseline, and then we explore efficiency-oriented extensions, which are inspired by TeachClip, on top of XClip using some lightweight adapters. The two datasets we use are MSR-VTT as well as MSVD, which we will go into more detail later. So next, I'll talk about our overall methodology. So like mentioned before, we apply parameter-efficient fine-tuning approaches to an existing VTR model. In this case, we choose XClip, which fine-tunes a clip model and compares textual and frame representations with 4 different similarity scores. This is the attention over similarity matrix, or the AOSM, like mentioned before. On top of this, we apply adapters to the encoder outputs before the similarity calculation. We also consider adapters within the clip transformer. So as you can see here, we have the text encoder as well as the temporal encoder, which feed into our text adapter and visual adapter, which then feed into the AOSM module. So these adapters consist of a down projection followed by an up projection, and the outputs of these adapters are added to the original representations. So here we have the two datasets we're using. First of all, MSR-VTT is a dataset of 10,000 web video clips, as well as 200,000 manually annotated captions for them. We also use MSVD, which is a dataset of 2,000 YouTube videos with 40 captions each across a variety of domains. For our metrics, we use metric standard to the related literature. We consider video to text as well as text to video retrieval. We calculate recall at rank K for 1, 5, and 10, as well as median and mean recall. So next, I'll talk about some of our results and a discussion of them. We compare against XClip, where all clip transformer layers are frozen, and for our approach, we freeze the backbone of clip, and then we fine-tune with adapters as well as the additional XClip method. So here we have the results for MSR-VTT. As you can see here, we observe that when we apply these additional adapters on top of XClip, we get substantial improvement at different ranks for recall. For both video to text retrieval as well as text to video retrieval. But there are some current problems with our approach and some future directions we can explore. Right now, we have limited leverage as the adapters are placed outside the clip backbone, and we don't really have much influence on deep cross-modal alignment. Additionally, we're also exploring transformer layer adapters. However, these attempts are currently unsuccessful due to some tuning issues as well as pre-trained weight mismatches. Additionally, we only evaluate for one seed, and the lack of multi-seed evaluation makes it unclear whether our improvements are meaningful. And right now, we only have experiments for MSR-VTT, and we'd like to validate our approaches on additional benchmarks, like the second benchmark we mentioned earlier. In conclusion, we observed that adapter-based fine-tuning offers a lightweight, promising, and still underexplored way to further improve XClip beyond its strong zero-shot baseline. Here we have the references for the papers as well as the datasets we mentioned. Thank you.